So the next two lessons are about preparing solutions in the lab and diluting acids. And there does need to be care taken when you are working with preparing solutions. Solutions are often made in a volumetric flask, and that is so that you can measure accurately the volume, and it has a handy bulb, which is great for holding onto it and making solutions. You also will typically use a graduated cylinder and a pipette. And the steps to creating a solution is to first measure the mass of the solute on a balance, so you have an accurate amount of the grams being prepared in the solution. You dissolve the solute in the water in the volumetric flask. Then you measure out more water using the graduated cylinder or using a pipette to dilute the solution to the required volume. And then you mix the solution thoroughly. It's important you store the solution in a WHMIS labeled container. And though safety label, the WHMIS label is important so that people know what it is they're working with. A stock solution is a concentrated solution that you could prepare for the lab or to be put in storage. And then scientists would then dilute that concentration to whatever % concentration they needed. So if we had 250 mils of 0.3 molar orange juice and concentrate, how much water would you need to add to make it 0.1 molar orange juice? So you're diluting it, you're going from 0.3 molarity to 0.1. You would use this formula. Concentration 1 times volume 1 equals concentration 2 times volume 2. The concentration of the first solution is 0.3 molar and it's 250 mils. You're trying to get it to a 0.1 molarity concentration. So this becomes a basic algebra question. You isolate for V2 and you get 850 mils. So therefore, taking the 850 mils, subtracting the original 250, we know we need to add 600 mils of water to get it to 0.1 molarity. This formula works for adding water to aqueous solutions with concentrations in volume per volume percent and mass per volume percent. So what volume of water would you need to add to a 120 mils solution of that 30.5% of sucralose to make it 26% grams per milliliter? You're going to use percent times volume 1 equals percent times volume 2. The first percent is 30.5, and that's at a volume of 120 mils. The second percent is 26%. So you would do some algebra, so isolate for V2 and you get 140.8 milliliters. Subtracting out the initial 120 mils, you know you need to add 20.8 mils of water to dilute that solution. Some extra special safety considerations need to be taken when you are diluting acids. It's extremely a dangerous process because it can be exothermic, give off heat. And it also releases hydrogen ions. And the positive hydrogen ion can immediately bond with the water molecule to create hydronium, and that's the exothermic part of the reaction, releasing lots of energy. So when you're diluting an acid, it's important that you always put the water in the volumetric flask first and then add the acid. Do not add the water to the acid. You start with the water and you add the acid to the water, because the water will float on top and get very heated and it can boil and splatter out of your container. So you do not want to add the acid to the water. You want to start with water and add the acid to it. So here's 3 questions you can practice. What volume of distilled water do you need to add to 350 mils at a 3.5 molarity solution to get it diluted to 0.616 moles per liter? And you dissolve 10.3 grams of sucrose into 250 mils. What's the concentration? And if you added 500 mils to the water, what's the new concentration? I'll give you the answers here. You should practice this and make sure you can do these examples on your own as well.